What up? We're doing entry 3, measurement and conversions. Apologize for shouting. So your notes should be downloaded. You should be editing. Here again, you're writing in the reds. Feel free to pause the video as needed. So SI units are used for consistency in science. So all scientists use the SI units. They're kind of standard. It's a standard international system. And that means that when I share data from the US to Europe or vice versa or across the world, that we're all using the same units. And we use prefixes on those units for very large and small measurements. So a typical unit would be like meters or grams or liters. These are what we call our base units. And then by adding prefixes like kilo, we can make that number bigger, or centi, we can make that number smaller. Okay, so the table here, there's all these prefixes. The big thing I want you to focus on are these ones right here. And I'm not going to teach you the really complex way of converting. We're just going to basically be counting pieces. So I attach kilo, centi, and milli. Notice that they're all represented by 10 to the power. That means 1,000 right there, or 1/100th, or 1/1,000,000th, or sorry, 1,000th, millionth. What am I talking about? 1,000th. So think of it like 1 cent is 1 penny. How many pennies does it take to make a dollar? It takes 100 pennies. So it's 1/100th. A cent is 1/100th of a dollar. Okay, so that's what that means. Or a kilogram, there's 1,000 of them. There's 1,000 grams. Or a milligram would be 1/1000th of a gram. Okay, so that's what it's telling you is added. So now the easiest way to do this is just get a nice metric conversion chart using a number line. Draw it in below. I would prefer you use this one. So if you want to draw this one into your notes, actually added it into your notes. Never mind, that one's in your notes. So that just means that all I do, if I have a roll of copper wire that's 15 meters long, what is the length of the wire in centimeters? So my thought is, how do I go from 15 meters to centimeters? Okay, that's the question that I'm asking myself. So I look at here, and meters is a base unit. And then I want to go 2 spots right. So to convert to a smaller unit, I just move the decimal point right or multiply. Easiest way to do it is just be like, okay, 15. Where is my decimal point? It's right here. I'm going to move my decimal 2 spots right and then add some zeros. So I get 1,500 centimeters. There are 1,500 centimeters in 15 meters. Okay. And a meter stick, believe it or not, is 1 meter long, which is why it's called a meter stick. Okay, that comes up later. There's 100 centimeters in a meter stick because 1 centimeter is 1/100th of a meter. Goes that way. If I go the opposite direction, I do it that way. So on page 3, I just want you to try a few. We're going to do the odds here. So let's pause and just take a minute or two to try the odds and see if we're doing it right. And then I'll go over the answers. Okay, here I'm going from milli to deci. So milli to deci is 2 spots left. So I'm going to move my decimal from here, 2 spots left, which is going to give me 0.35 deciliters. Now deci is a less common one. We're going to focus mostly on kilo, base, centi, and milli. Grams to kilograms. Grams, I'm going 1, 2, 3 spots to kilo. Okay, so that means I got to move it 1, 2, 3 spots left. So 0.95, and if you kept that 0 on, that's just fine, 950. Okay, if you left it off, that would also be acceptable. In general, we would drop that one off for very complicated rules that we will not go over in this class. So milli to centi is 1 spot left, so I move it over, it's 27.5 centimeters. Oh, what am I doing? I'm doing all the problems. Let's just do the odds. Milli to liters, 1, 2, 3 to the left. 1, 2, 3 to the left, that just gives me 1 liter. Here I'm going 25 centimeters to millimeters, that's 1 spot right. So move it 1 spot right, giving me 200, that's a 2, and 50 millimeters. 9 meters to centimeters. Meters base, 1, 2 to centimeters. It tells me I'm moving 2 spots right. That's 7.5 centimeters. Okay, you can take the time right now and to finish the rest of them, and then when you submit, we can check our answers later. Okay, now dimensional analysis. I already kind of started this. This is when I'm not going from metric to metric. I'm going from English units to metric. Here in the United States, for some reason, we chose to use the imperial system. And as you can see, in this system, nice easy numbers. I just got to move a decimal around, right? Metric system, how many inches are in a foot? 12. Can't move a decimal, I got to divide or multiply. Same thing with yards, miles, pounds, gallon. Okay, all these things. There's how many ounces in a pound? 16, right? Well, how many grams are there in a kilogram? Kilo means 1,000, so there's 1,000. So the metric system is just a much simpler system. I believe it was Jimmy Carter was going to switch us over in like the 80s. And then we got partway through and we just kind of bailed on it. So the United States could be doing the same thing as literally everybody else in the world, but we decided to be our own country. So to convert from English, inches is English, to metric, we have to use what we call a conversion factor. Now, this is really important later on in your science career to get to chemistry. So what you do is you read the problem and you figure out what's my starting number, 100 inches. I'm going to write that out over here on the left. If it's helpful, you can put it over 1. Same thing with kilometers down here, you can put it over 1. The reason why it's helpful is because we're really multiplying fractions here is what we're doing. Okay? Now, whatever units I start with go on bottom of my conversion factor. So that's inches here. Whatever units I want, how many centimeters, that goes on top. And then in here, these two numbers, these are equal. Okay, these two numbers are equal. So you have to ask yourself how many centimeters is equal to an inch. I go over here, 1 inch is equal to 2.54 centimeters. Okay. Now if I was multiplying fractions, I'm going to take 100 times 2.54 divided by 1 to give me 254 centimeters. Okay, so let's go through the same process in this next problem, right? So I have 600 kilometers and how many miles? So I start by writing the number I start with, 600 kilometers here. And then I'm going to put that on the bottom, that label on the bottom for kilometers. Common mistake, people write 600 down here. We haven't decided what units what numbers go in here yet. Remember, they just have to be equal in here. So miles to kilometers, kilometers is on bottom, it cancels out. So notice if I were to take an arrow through down here, inches cancels out, kilometers cancels out, leaving me with miles, Okay, so it's 1 mile, so 1's going to go with mile now. Notice 1 isn't always on the bottom or always on the top. It depends. It's still going to be multiplied. Kilometers, though, is 1.6. I'm going to abbreviate to 1.61. So 1.61. So I take 600 times 1 divided by 1.61, and give me a second to punch in my calculator, and I get 372.7 miles. Now you're going to ask yourself where to round. We can just use 1 or 2 decimal places is fine. There's some more strict rules about how to do that, but they're very strange to learn. Okay, so we're just learning how to do dimensional analysis. So what I want you to do is go to page 3 after we complete this problem here and try a couple. We'll go through them in a second. So this example, let's see where we are for time here. It says the sheet, roll toilet paper has 300 sheets in it. This is just kind of a solve problem, build it out. Each sheet is 10.1 centimeters. How long is the roll? So if I multiply 300 times 10.1, I get 30.30 centimeters. How many meters is that? Well, I got to go back here. Centi to meters is 2 spots left. Personally, I think this problem is a little out of order. I apologize. So that's 30.30 meters. You could pause and try though. Okay, so meters to kilometers now. What do I have to do? 1, 2, 3 spots left. 1, 2, 3 spots left gives me 0.030 kilometers. Okay, or millimeters from millimeters from meters. I have to go 1, 2, 3 spots right. So that's going to be 3030 millimeters, lowercase here, lowercase here. Make sure you abbreviate the correct way. Okay. Now here are tried other dimensional analysis problems. So I tried A and C. You can try the other ones on your own. The question you should ask yourself, okay, I take my starting thing, I'm going to write it over 1. If that's helpful for you, don't have to write it over 1. Centimeters goes on bottom to cancel. Inches is on top. And I have to look at my table. Remember, these are equal. So these two numbers here are equal. 1 inch is equal to 2.54 centimeters. So I take 734 times 1, which is 734, divided by 2.54, gives me 289 inches. Okay. Here I got meters to yards. Meters is going on bottom to cancel. Yards is going on top. Yards. And I come over here, I got to find meters to yards. So it's 0.9144 meters. I'm going to say 0.9144 meters. That's a 9. And 1 yard. Okay. So a yardstick is not the same as a meter stick. They're close in length. So it's 20 times 1 divided by 0.9144 is going to give me 21.9 yards. 21.9 yards. Okay, so try these other two. And we got one last topic to talk about with measurement is, and I'm not going to talk through each of these. These are just what we're doing with each. We got length, mass, volume, and weight. We've actually already talked about all these. Mass is measure of stuff. Mass times gravity is weight. Length is the distance, and volume is the amount of stuff. Okay, so pause the video here and make sure you write all those down. Make sure you know the units. Length is meter. Mass is grams. Volume is liter. And weight for us is going to be pounds. Pounds. Okay. And this is where we get our table. You can fill this in here. So length, mass, time. These are the SI units. Okay, these are the SI units. Length variable is the L. You'll see in the equation. It's meters or lowercase m. Mass, lowercase m, grams or G. Okay, temperature is T. It's Kelvin or Celsius. So it's Kelvin, or to note, it's degrees Celsius there. And substance and current. These are things you'll see in the future. Moles is the biggest one you'll see in the future as well. So copy that down, pause the video. I'm moving on because I got time. So scientific notation is a way to represent really big or small numbers multiplied to the power of 10. Now the nice part is the exponent tells you how many digits to move it. Okay, so pause the video here if you need to. So 6 means I'm going to move my decimal 6 spots. Positive means big. So positive equals big. That's the big thing here. Negative means it's small or less than 0. Or less than 0. Okay, so here 6 would mean it's a big number. Negative means it's a small number. And it tells you the number of spots to move it. And now this is a way to represent numbers that are really big or really small. Last piece of vocab, whenever we are measuring, taking measurements, precision and accuracy, which we talked about already in a previous video, are exactness or close it is to the actual measurement. Which one's more precise is whichever one you're going to do more consistently, probably the measuring tape. Which one's more accurate? Definitely the measuring tape. Okay, so now this is scientific notation, so we got to adjust this here. The one thing to note is I only want one digit in front of the decimal. So this is going to be 5.0 times 10 to the 1, 2, 3, 10 to the third. Okay, this is going to be 8.0 times 10 to the 1, 2, 3, 4th. There's only one number in front. Here, this is 1.0 times 10 to the 6th. Here, this is 2.5. So this is where you see only one number in front. And I had to move it 1, 2 spots. Since it's small, it's -2. This is going to be 5.0 times 10 to the third. And if you have questions about this, I know you've seen it, so I'm going through it quick. Might run out of time here, but I got to make it bigger by 3. So it's going to be 1500. and here I got to make it smaller by 1, so it's 0.335.